Mr. Pankaj, you can you can start sharing the screen.
I'm unable to share my screen.
Okay, I think the admin needs to give right to you. I think that is not there.
It is not allowing me.
Just check, Mr. Devna, that he has sharing rights.
But the right has been given to him.
Maybe you can just undo and do it again. Sometimes it freezes, right? So.
Should I exit and then join?
No, that shouldn't be necessary. Just wait along. Let him just try again.
Okay.
So in the meanwhile, if there is any question or any thoughts in your mind, I mean, philosophical thoughts is also important for doctors to discuss. We are looking at equally competent ecosystem working hand in hand with us. So drop it in the chat box. Let's keep on discussing questions. You can put it in the question box. We'll be happy to take them. If you have the answers to any question, you can also write in the chat box. And as I will again reiterate, this is a phase where we learn all together. So there may be answers which you will give better than me. So feel free to help me figure it out. Okay. Are we getting it solved?
So?
Mr. Devnath?
But I have given everything.
Okay.
No, it is not allowing me.
Okay, what's happening? Will I be able to do something also from my side? Let me check.
How?
Do we have anybody from the admin team, from the tech team here that can assist in this? I think, Mr. Pankaj, you can just log out and log in. That's possibly the best thing. Just go out of the screen and log back in the same link. Okay, so gives us a coffee break. So let's utilize that. I will utilize this time to announce to you all that as esteemed members of the CCAIM program, we invite you all to join us in the Doctors AI Global Summit in September in New Delhi on 19th and 20th of September. As you all know that we conduct 2 or 3 batches every year, and we have a convocation ceremony for all of you who are going to be completing the course. So this would be the right time to register for the event, because we are on the early bird registration. And the early bird registration, if you're a member of the Indian College of AI in Medicine, is very nominal. It's only 5,000 rupees. So if you are a member, then you can quickly register for the conference, because you're sure to attend the convocation. And there are some excellent photographs which are there on our websites and socials that you can look at with the previous batches. And we'll love to have all of you, this entire learning journey of 3 months, where you all connect with each other, work in a group, you come back, and meet each other. It's a fantastic, way of interacting. So we'll invite you all to register for the conference quickly before the early bird runs out. And if you're not, I will drop some of the links in the group, in the WhatsApp group, where you can become the member of ICIM. And then in a couple of days, once you get your membership number, you can avail the early bird registration. But I will be expecting, and all of us from the Doctors AI organizing committee, we will be expecting that we see all of our CCIM alumni members join us in the conference. Dr. Sripal, AI will definitely help in sorting the technical issues if we train it to do that, yes. Is it not necessary that general GPT, while giving answers to health queries, of giving general disclaimer to give specific limitations of AI gaps? Yes, sir, Dr. Arun, it is necessary, and that's the whole fulcrum of using AI responsibly, that we give a disclaimer when we're using a general language model for answering. We know the limitations of it, and if we are using AI, we can say this is an AI generated answer. This is going to be a very important segment which we will discuss when we talk about using AI for research paper writing. And that's where we'll talk about giving all the acknowledgements and the disclaimers, etc. The new terms are going to be repeatedly discussed, Dr. Basav Raj, as we go along this journey. It's just the first set of discussion happening today, and I'm sure down the line we will have many more times these terms are going to come up, and nuances and contextual examples will be set to you all. So by the end of this course, you will get familiar with all the basic terms. Okay, somebody found an answer to Dr. Mundi's question in ChatGPT, so that's automated intelligence for you. Would you suggest Dr. Prashant found the answer to Dr. Mundi's question? Yeah, I can see the screen sharing is on.
Sorry,
Yeah, over to you,
can't,
Professor Pankaj. Go on.
I can't share my video. It is not allowing.
No, it is you.
We are seeing your
It can be seen now. It can be seen now. It's okay now.
You can see my screen, but I can't be seen because my video, it is not allowing me. It is showing that the control is not there.
But we can see you. We can see your
You
presentation.
can just go to your slide and start presenting. We can see.
But then, yeah.
Yeah.
We can see.
Okay, so let me. Good evening, everybody. So after a heavy content-rich session from Dr. Amit De, let me take you through a journey of the most powerful, the raw material for healthcare analytics is the big data. So this is the session which will give you very, very clear understanding that what exactly is the data, big data, and big data analytics role in the healthcare. So let me start with the today's session coverage, what exactly I'm going to discuss. Many of you are already familiar with the healthcare data, but we have to start the journey of understanding what exactly is the healthcare data, and then how this healthcare data we'll be using in our AI applications in all the three areas, like in the traditional AI applications, in the generative AI, and agentic AI. Now, our course will focus on all these three areas, and we will be using these approaches to solve the healthcare analytics problem by using low-code, no-code tools. And when we'll be using these tools, we have to use data. And most of the time, we'll be using the data which will be coming under the category of big data. So what exactly is the big data? We are going to understand that today. What are the sources of this big data in healthcare? And how do we solve these big data technologies for using this data in our healthcare analytics applications? We will see some use cases, and then what are the challenges in this healthcare big data analytics. There are certain data privacy, security. We will be having that sessions in detail, but today I will touch upon that what are the challenges in the healthcare big data analytics. Now, the objective of today's session's outcomes is to get a clear understanding of the healthcare big data and its strategic importance. Remember, the topic is big data analytics and the technologies. Now, what are the big data technologies which are used in large scale in the healthcare analytics applications? We'll also understand how these techniques enhance the big data analytics for predictive, real-time, and personalized healthcare applications. And also we will see the practical challenges and the governance issues. Now, if I start with a very, very fundamental concept that what is data? So data basically refers to the facts, figures, and observations that is stored in the digital form and is used for analyzing to generate meaningful insights. Dr. Dey has just spoken about the evolution of AI and the different type of decision sciences, and a little bit he has spoken about the artificial intelligence and the different types of artificial intelligence. But in back of this is the data. So data can exist in various forms like text, numbers, images, audios, videos, and this data is classified or is categorized into typically in the three different forms we call structured data. The structured data comes from the databases and the spreadsheets. We have unstructured data, which comes from the emails, medical notes, and then we have semi-structured data, which are coming from JSON, XML, and all this. Now, when we have unstructured data, which is coming from the different type of medical observations, that's the biggest challenge that we need to handle with the help of big data analytics technologies. Now, if I classify this healthcare data, we have patient data related with the demographics, medical history, diagnosis, treatment records. We have clinical data, operational data, genomic data, and in the today's world, we have a lot of wearable and IoT devices based data, which are continuously getting generated on a real-time basis. And it is also used for a real-time monitoring. So now we have understood that what is this healthcare data. Now let's see in this entire healthcare data analytics value chain, considering in the healthcare analytics, so we have structured data, we have semi-structured data, we have unstructured data. Now this data comes into our analytics value creation or value chain process in three stages. We have data engineering, where we do integration, we do transformation, we ensure the data quality, data cleaning, and multiple rule engine. Now, once you get into the data engineering, then we enrich the data. How do we enrich the data? We store the data in the form of data lake, data warehouse. Now, why? Why it is required? Because, see, the data warehouse is called multi-dimensional database. Every data entity have multiple dimensions, and we create the data warehouse or a data mart for extracting intelligence from the different dimensions of the data points. Whereas if I take data lake, this is the concept which are nowadays used. Data lake, data sandbox, these are used today for analytical applications. We'll be doing this in much more detail. And then we come to the data science applications, where we are actually applying different type of statistical analysis, machine learning, deep learning, NLP, text analytics, and all those things, and we are extracting the insights. Now, when we do this, the below point is called data literacy. Now, what exactly we need to do? We have to have a pipeline management. Then we have to have a deployment, automation. We need to do a flow security, scheduling, data orchestration, flow control. And this entire thing will make the entire environment data literate. And then finally, we give the value. So we have recommendation, prediction, optimization. Then we can also have visualization, dashboard, medical data dashboard, and also different type of enterprise applications, data sharing. and also different type of apps which can be given to the multiple stakeholders. So this is the data analytics value chain, and in this value chain, the most important thing is our data. Now let's come back to the importance of the healthcare data. It enhances the diagnosis and the treatment planning. It improves the patient outcomes and safety. It also supports predictive analytics for disease prevention, optimizes hospital and resource management, and it enables AI-driven healthcare innovations and many more. In the today's world, healthcare innovations is happening on a day-to-day basis, on a regular basis. And this is only possible because we are using data in multiple ways. And in that using of data is done with the help of some technologies. We are going to learn that, we are going to see that how these technologies are used. Now today's session is on understanding the big data and its relevance in the healthcare. So how do we say that this is a big data? So big data in healthcare, it refers to the extremely large and complex data sets. Now remember, let me explain to you what is data set. So data set is basically a combination of observations which are having multiple data points. Now, when I'm saying that observations, these observations are coming from multiple data sources, and it gets converted into a data set forms by doing some sort of ETL activities: extraction, transformation, and loading. Now, ETL is done in two perspectives. One, let's suppose I am getting a data from CT machine, CT scan, and I'm also getting data from my EHR. Now, what I need to do is that I need to transform both of these categories of data and bring it to a particular form. And this transformation is an ETL, extraction, transformation, and loading. But finally, I may have to do another ETL to bring it to a ready state of data set from where I'll be using my analytical applications. So ETL is a continuous data engineering applications and is a part of the data science healthcare applications. So the 5 V's of a big data is volume, velocity, variety, veracity, and value. So these are the 5 V's. Just 1 second, there is some noise coming. Oh. Give me 1 second. Okay, so now let's try to understand the big data in a slightly better way. So we have healthcare data coming from the electronic health records. We have medical imaging data coming from X-rays, MRIs, CT scan, genomic data, wearable devices, clinical trials, research data, patient feedback and social media data, health insurance and billing system. You can imagine that the complexity and the volume of data that is coming from multiple sources, and this data needs to be used, needs to be transformed, and then it has to be ready to extract intelligence from the entire data sets. Now this is a very basics, and let's understand this very clearly. Now when I say big data, now from where I should say the big data? As we all know that one bit is the smallest unit of storage of data. So 1 byte equal to 8 bits. And if you see this table, so when we have, the petabyte or exabyte, from this level, we start referring this as the big data in terms of the size. Whereas the other attributes of the big data vis-a-vis small and medium data is represented here in this particular table. Now, if you see this, the entire data can be classified into small data, medium data, or in big data. So if I take the size, so small data, it is in kilobyte or megabyte. If I take the medium data, it goes into gigabyte or terabytes. And big data is terabyte to petabytes or more. That means if you see this, terabytes to petabytes, exabyte, zettabyte, and more. So that's the size of the data that we deal with in the big data in healthcare. Now, in terms of the storage and processing, if you see the big data, it requires distributed cloud storage and high performance computing, HPC. And earlier days we used to process the data in multiple storage devices. And today the technologies has come where you can also use GPUs, and the GPUs in the multiple distributed cloud storage to process the big data. Now, what is the technology that is used? Management technologies. In the big data, you have big data framework where we use Hadoop, Apache, Spark, NoSQL, like MongoDB, AWS, Azure. These are the management technology tools which are used in the big data in healthcare. Now, what is the processing speed? The processing speed, it requires real-time and parallel processing, AI/ML for large-scale analytics. Now, when we develop a small applications, it is using a very small segment of the data. But as you go, you have to use the entire enterprise, healthcare enterprise data. So it needs a large-scale analytics, processing, and continuous monitoring and managing this. The complexity of the data, if you compare with the small, medium, and big data, the big data comes with structured, semi-structured, unstructured, from all sources, coming from medical images, genomic sequence, IoT, sensor, social media, and so many other sources of data. And the velocity of creating this data is very high. It is coming on a real-time basis, continuous basis. So managing this becomes a big challenge. And to manage that, we have big data analytics techniques, which we are going to discuss now. Now, take an example of this healthcare data types. From the EHR is very big, very high, TB to PB, terabytes to petabytes. The velocity is medium. Variety, it is a structure, data coming from the tables and the records. And the veracity is very high, very high. And the value, it improves the patient's care and diagnosis. Now, we can give attributes to all the different types of healthcare data in terms of these 5 Bs. Am I clear? Any questions, please ask me. Now let's move to what are the technologies which are used in managing this big data in the healthcare application. So we have multiple big data technologies, Hadoop, we have, HBase, Cassandra, and there are multiple other databases which helps us in managing this large volume of data in the big data technologies applications. So I will discuss about this a little bit for each of these cases. So we have Hadoop, we have Hive, we have Apache Pig, we have Spark, and HBase. HBase is basically a NoSQL database, like we are using a database like, MySQL or SQL Server, Oracle, or IBM DB2. Now, these are the databases which are used, and these are structured data. Whereas in a big data categories, we use unstructured or NoSQL data, and The NoSQL data which used widely is the Apache HBase. Now let's try to understand these technologies and their impact on the healthcare data. So if I take Hadoop, Hadoop is an open source framework for storing and processing large data sets in a distributed manner using the Hadoop distributed file system, which is called HDFS and MapReduce. Now, what is the help that it gets in the healthcare data? It helps to store and process large EHR data, patient history, and genomics data. Example, a hospital network uses Hadoop to store 10 years of patient record across multiple locations. Now, you have a large volume of data. So this volume of data, how do you manage to process? If you have to use some sort of AI algorithm, machine learning algorithm, you need to read the data. If the data is available in the digital form, so you have to read the data, you need to apply that into the data model, run the model by segregating them to train the model and test the model. Now, how you will do this? So you need some technology to manage such large volume of data. Now come to the Hive. Hive is a data warehouse system built on top of Hadoop, and that allows querying and managing large data sets like HiveQuery. HiveQuery is like an SQL-like queries, but it is used on a unstructured NoSQL database. And how it is used in healthcare? It enables the data analyst to run queries on patient data without writing a complex MapReduce job. So map job means an activity. Now take an example of pig. Now what is a pig? Pig is a high-level scripting language that simplifies complex map-reduce jobs using pig Latin. Now these are a little bit technical words, but these are used for managing a big data in healthcare applications. You have Spark. Spark is used for in-memory big data processing framework that is much faster than Hadoop's MapReduce. The real-time processing of IoT-based patient monitoring data is done with the help of Spark. And you have HBase, which is a NoSQL database, which is built on a Hadoop for handling large amount of structured, semi-structured data. Structured and semi-structured data gets stored into a database. Now, what is a database? Database is a collection of data tables. Now, what is a table? Tables are the storage methodology by where the data is stored into rows and columns. Like, in Excel file, we have multiple rows and multiple columns. So similarly, in the database, we have multiple database rows, and the rows have multiple data elements, which we call data field. Now, this is done with a NoSQL database using HBase. So if I see that what are the important big data analytics technologies which are used on big data, big healthcare data. So we have Hadoop, we have Hive, we have Pig, we have Spark, and HBase. Now let's try to understand a little bit about the big data analytics in healthcare. What exactly we do in the big data analytics. Take an example, a couple of examples. So we have, if you see the image on the right-hand side, you have telemedicine, you have population health management, drug discovery, real-time alerting, electronic health records. Now, these are all big data analytics applications. And if you see on the right-hand side, you have predictive analytics for disease prevention. Now, AI analyzes patient history to predict disease risk, diabetes, heart disease. Now, these applications are typically based on using machine learning, deep learning, and the traditional algorithms. Whereas if you start using the generative AI, or if you are automating a repetitive work using agentic AI, so those applications are different. For a large hospital, managing the healthcare data, you need to use the traditional AI approach. All large healthcare applications, it runs on machine learning. You will be very clear after a few days that machine learning, deep learning, NLP, and how it is related with generative AI and agentic AI or AI agents. But today, let's try to understand when I'm developing a healthcare application for a large healthcare organizations, we need to manage the large volume of data, large volume of healthcare data. And here, to manage that healthcare data, we need computational infrastructure. And computational infrastructure means managing the digital form of the data, storage, and also need to have access to use the data, the read write operations of the data. And for that, you need a technology which can help you to store, manage, and access the data. So that's the big data analytics technologies. Now let's try to understand a few more applications. You have genomic data analysis for personalized medicine, where we do genomic sequences and provide specific drug recommendations. Now this needs a special type of large volume of data to handle. You have operational efficiency and hospital management. Now here you need to manage multiple data coming from the various functions of the hospital, from patient admission to treatment to other clinical and non-clinical data that need to be managed for developing an efficiency applications using AI. You can also have fraud detection in the healthcare billing. Now this is another applications which is related with the medical claims and the financial implications. How do you validate the various type of clinical data, non-clinical data, and the claim data, and come out with some fraud detections, do some sort of predictions. Now these are the large data driven healthcare applications, AI applications. These are called enterprise level applications. These are healthcare enterprise level application. But being a doctor, if you want to use AI, you can use generative AI. You can also use agentic AI to automate certain repetitive work by using agentic AI tools and giving the relevant data which the AI agents will be using for giving you the outcome, giving you the expected results. So I hope it is clear. So if I consider this artificial intelligence, classifications, you have traditional AI, you have generative AI, and you have agentic AI. Now, agentic AI, you may not be needing a large volume of data because you'll not be able to manage and process that. If the volume of data is minimum, small data, I just shared you that small data, medium data, and big data. So if it is a small data, medium data, let's suppose you want to interpret some, X-ray image, it's a small data. But if you have to interpret 10 lakh X-ray images or 1 lakh X-ray images, you will not be able to do it under the category of small data or medium data. It will go under the category of big data, and then managing 1 lakh or 10 lakh X-ray data, X-ray image data needs some technology to process the data and interpret with the help of some AI algorithms. Okay, some more examples where exactly this key AI technologies can use in the big data healthcare analytics. So you can have machine learning predicting the patient readmission based on the historical data. So this is one example. And machine learning model predicts which diabetic patients are likely to experience complications allowing for early intervention. So you can do such type of prediction by using the machine learning algorithm, and that needs to use large volume of data and train the model, train the machine learning algorithm, and then test the algorithm and then use the algorithm for doing this prediction. You can also use NLP, deep learning, and other examples of predictive and real-time analytics. Now, very important thing is that when you start using this big data analytics for predicting hospital readmission, I have just given one example. So there are certain steps that you need to follow. The first is the data collection. Now, before you collect the data for any healthcare applications, you need to define that what is the problem statement. What exactly you are going to solve? What is the pain area? And to solve that pain area, how you are defining the problem statement. Now, once you define the problem statement can be a general statement, but then you have to go further down and define the problem statement into multiple problem definitions. And each definition should have an existing KPI, key performance indicator, and an expected KPI which you are going to target to achieve after successful implementation of the AI application. Now, based on this, you have to start understanding that what is the data that you need to use, how you are going to collect the data, collect EHR data, lab result. Now, linking the data related with the KPI and the problem definition to solve the large problem has to be very clearly defined. And for that, what we do, we follow or we maintain a data inventory. Now, data inventory is very important. We prepare a data inventory tables where we identify that these are the data that we need, whether this data is available. Sometimes it is available, but it is not accessible. Now, what is the way to get the data, make the data accessible in our AI algorithm and developing the AI model, AI data model? Now, once you have that clear understanding, then you get into the data pre-processing. You have to clean, normalize, and anonymize the data. Pre-processing is very important, and in the pre-processing, we do a lot of EDA activity, exploratory data analysis. Then we get into the feature engineering. After we complete the feature engineering, then we do the model selection and training the model. And then we evaluate the performance of the model. And then finally, and in that, we also find out what is the accuracy level, precision, recall. This all you are going to learn in the sessions to come. And then finally, once you are accepted with the outcome, once you are accepted with the result, then get into the deployment. Now, this is the workflow of the big data, and every stage you have to use the technology to help you to manage the data. Okay, so now let's try to understand in this entire world of big data analytics in healthcare, there are a lot of challenges that you need to face. Now, what are the challenge? And this is one of the important area where we all need to focus from the beginning. The healthcare industry is experiencing an unprecedented surge in data generation, which is driven by the electronic health records, medical imaging, genomic sequencing, wearable devices, and so many others. The sources of data is giving us large volume of healthcare data. And this volume of data comes under the big data analytics. And the most important thing is the transforming this vast data to get actionable insights. If you see the flow on the right hand side, from the data source to data collection, then data encryption, then you need to use some sort of fuzzy algorithms, and then get into the cyber security measure, because these are also very important. And then you have to create an entire, the data architecture. This is called data architectural framework. And based upon the data architectural framework, you need to apply the AI solutioning architecture. And then you have to come to the data science, flow and develop that what algorithms, what AI algorithm. Whenever I say AI algorithm means which machine learning or deep learning algorithm will be suitable for extracting the intelligence from the data which we have collected. Now, despite this transformative promise, the healthcare big data analytics has several critical challenges which are more complex and sensitive than most of the other industries. Other industries, be it is the manufacturing or banking, insurance. The healthcare data is very, very complex and it goes through a big challenges. Now, what are the most important challenges that we are going to discuss is related with the data privacy and security, interoperability, scalability, and data integration across heterogeneous systems. Because these are the challenges that you need to address. Now let's try to understand the data privacy and security. I'm just giving you a very brief understanding about the challenges of big data analytics in healthcare in terms of the four categories of challenges. First is data privacy and security. The healthcare data is among the most sensitive categories of personal data. And today, if you see in the Indian context, you have DPDP Act. So DPDP Act means Digital Personal Data Protection Act in India. Now, if you are developing an application or if you are using the data related with the United States, you have to follow the HIPAA. If it is for European Union, you need to follow the General Data Protection Regulation and European Union Act. Now, these are very, very sensitive. So any AI application, large scale application need to follow this data privacy and security under the regulatory compliance framework. The second challenge is the interoperability across healthcare systems. Healthcare data gets generated and stored across wide range of systems, including hospital information system, laboratory system, radiology system, pharmacy, insurance, public health database. You can imagine the data is coming from multiple sources in multiple forms. Sometimes it is coming in file, sometimes it is coming in databases, multiple files, and all the 5 V's are applicable. So what happened? The lack of interoperability standards need to be addressed, which becomes a big challenge for a healthcare AI application. That's for interoperability across healthcare systems. The third category is the scalability of healthcare big data systems. Scalable. Healthcare data volumes are growing exponentially due to high resolution medical imaging. Because high resolution medical imaging, the size of the data will be little on a higher side. Continuous streaming data coming from the wearable and ICU monitors, large scale genomic sequencing, long term retention requirement. That is another important thing, that how long the data, this large volume of data need to be stored, you need to retain. And then you have traditional data architecture which were not designed to handle the scale, velocity and complexity of the modern healthcare data. So there is a old traditional data and you have a modern style of data. So you need to consider both this data to scalability of your application. This is another big challenge. And then you have data integration across heterogeneous system. You have data, structured data coming from the lab results, billing record, semi-structured data coming from HL7. I think we will be discussing more on HL7, health level 7 data messages, JSON data, XML data, and unstructured data coming from the clinical notes, imaging, audio, etc. Now, heterogeneous data and managing this heterogeneous data coming into multiple forms is another big challenge. So these are the challenges that we need to face in managing big data analytical application in healthcare. Now coming to the AI application, unless until you cross these challenges, you will not be able to manage your data in a quality and structured form to extract intelligence using AI algorithms, machine learning algorithm, deep learning algorithm, etc., etc. So any questions till now? If anybody have any questions, you can. Is there any question? Hello? Any question? No question. Okay, so let's. Any questions? Am I audible?
Let me give access to them, na? Just a minute.
Oh.
So let us first, I think if the session is done, then let's just have everybody come on screen. And now you can all, you'll all have the access to speak and discuss and ask your...
Sorry?
Am I audible?
Yeah, you're audible.
Okay. So we'll have all the options to ask questions. So we'll ask everybody to keep your hands raised if you want to ask a question. You can also put it in the chat box and in the question section, and Professor Gupta or myself can take it up. And if you would like to ask or discuss it yourself, you can just keep your hands raised. So I can already see Dr. Kiran B has his hand raised. And you can go ahead with your question, Dr. Kiran. And also Dr. Maheen. And there are some questions I can see in the... Okay, there is a question. There's a couple of questions, Professor Gupta, you can take from the question section. Dr. Angeline,
Yeah, let me.
Yeah, Dr. Angeline wants to know, is big data same as high dimensional data?
High dimensional, am I audible now?
Yes, you're audible.
Yeah, high dimensional is called multi-dimensional data. Multi-dimensional data may not fall under the big data category. You can make them under the medium data category, not under the big data category. Big data, see, when I'm using the high dimension, again, you need to see whether all the V's are applicable in the data set or not. If the volume is very high or the variety is very high, and from there you are creating the multi-dimensions, then if it is following these V's, then you can put them under the big data category. Otherwise, they will be medium data. Have I answered your question, ma'am? No, can't hear the answer. Yes, no.
Yeah, I think all of you have got access to the mic, so you can now use... Yes, Dr. Angeline, I can see you on the screen. You can... You just need to unmute. If you all need to speak, you can just unmute and speak, because I think the microphone access has been given to all of you.
Which is ideal for the big data analytics for healthcare? Which is ideal for big data analytics? Okay, let me answer this question. The big data analytics is applicable when you have large volume of structured, unstructured, and semi-structured data coming from the multiple sources. Now, this type of analytics applications are used in hospitals, in diagnostic centers, in medical colleges. I have developed several such type of applications where I'm using machine learning and deep learning algorithms and managing the large volume of data. And this management needs a lot of analytical techniques, like what I've explained now. So that's the way. But if it is a small application where you need to extract intelligence, you Can do it by using generative AI or agentic AI. Yeah. Any other questions? I wanted to know the.
Yes, there is one more from Dr. Sripal. You can just check on the question section.
It's not scrolling down. I can see only.
Yeah, there's a question from Dr. Sripal Jain. How easy or difficult is it to analyze real-time big data like an ICU data?
No, see, if you are using the real-time data, so you need to have a data pipeline approach where this real-time data will see. I'll tell you one thing. I have handled the real-time data also. In the real-time data comes from the IoT devices on a continuous basis, and that data is basically a sequential or line sequential data.
Right.
So you need to understand that where exactly you need to break the data, at what frequency, at what time interval, and then put it into a particular structured form. And that structured form may be a database table or maybe a file systems. And from there, you need to do some sort of ETL. ETL stands for extraction, transformation, and loading. And that loading, after you load this, then the data is ready to use for your data set. Still, it is not clear. So then again, you need to do some sort of data cleaning and some sort of feature engineering, and then take the data to your AI application. So there are a lot of data science applications happen in between. So that's the way it is used. Yeah.
Yeah, so I think that explains. There is another question. Mostly these are all on data, so we'll let you take it. Is it true that true as such that data has zero values unless human expertise is added to it? This is from Dr. Arun Kumar in the chat box.
What is that question? I can't.
Dr. Arun, you want to unmute and ask the question? The question is it true that data has zero values unless human expertise is added to it? So maybe you can explain.
Human. Yeah. Data has zero value unless until data gets created from the human generated systems. Okay. Now, if you consider the X-ray or CT or MRI, the human has created these digital devices to capture data. What is the AI is doing? AI is extracting intelligence from a large volume of data from his trained model. So you have to first use the large volume of data to train your model, and then you have to test the model. Once your model is tested, and it is, let's suppose in a healthcare application, typically what happens that your accuracy level should be above 90-95%. Then only you'll be able to see. Human intelligence is also not 100%. So we need to ensure that my AI generated outcome is more than 90% accuracy level. Rest of the decision is human in the loop. So doctor has to also put his or her intelligence and take the final call.
Right. Okay,
Yeah.
we'll take a few questions from the certain doctors whose hands are raised. Dr. Basavraj, you can go ahead with your question.
Yes, sir. Sir, I would like to know about the reliability of big data.
Reliability.
Yes, sir.
See, big data is always reliable. If you are taking the data, X-ray data or CT data, MRI data, and so they are all reliable. Now, in terms of the accuracy of the data, see, when you are capturing the data in an X-ray, and if there is some error while capturing the data, you need to purify this data. You have to clean the data. I have developed an application called Chest AI, and in the Chest AI is a chest X-ray data I'm using. I have more than 1 crore of X-ray data. But before I use this data to train the model, I have cleaned the data based upon different parameters. and the data which were not as per the expected format, we have rejected them. So can you imagine 1 crore chest X-ray data, image data we have used to train our model. Now the data need to be cleaned, and the cleaning process needs certain, parameters which need to be considered based upon the problem that you are going to solve. The problem statement and the problem definition need to be understood very clearly so that you can consider the type of data and the parameters of the data. So whenever it's a big data you are taking, the big data, whether it's an image or a video or a sound or a mixture of all, you need to define some parameter to make the data clean before you take it for the analytical application. Hope Dr. Bashabraj, I have answered your question.
Yes, sir.
Dr. Murli?
Thanks, Amit. I hope I'm audible. So
Yeah.
A couple of questions here. One is what Dr. Gupta said.
Yeah.
He was talking about a large data set, but I think what you missed out is that the training is separate for every use case. If you have 1,000 diagnoses, you need a separate training for all 1,000, or you can do one instance of training for 100 diagnoses. The chest X-ray, if it is just the lung, you could have 1,000 different diagnoses, or even if it is a nodule, you could have hundreds of them.
Yes, possible.
Yeah. So how do you do that? You train for every instance, or you train them for a batch, or how do you do it?
No, so generally we do for a batch, not for every instance.
So if all these for each of these diagnoses, you need to train the model?
Yes.
So that means your real time does not really remain real time, does it? There is always going to be a latency in that, because for radiology it is fine, but but suppose if there is an ILR or something, a loop recorder or something, or a Holter sending a stream of ECGs, and you have to detect an arrhythmia, the system that you said that it will take interval data, it will tabulate it, segment it, and then put it to the model and then give an output. What will be the latency of that?
Yeah, it all depends upon your computing power, And today what we do that in a large data sets, we take the relevant data points which are required to be used for interpreting that particular output. We don't take the entire thing. That is why you need to do a lot of transformation of the data.
But here in medicine, it's very difficult to say what is relevant, what is not relevant. Sometimes the most unusual diagnosis will hit you in the face, and that's where this technology is more important.
Yes.
What do you say, Amit?
In the context of technology, Dr. Murli, I completely get where you're coming from. So, and I think we will head into that segments somewhere in the course. You will see that the neural networks primarily also uses recurrent neural network, and that's where you're looking at time series data. So that is where the advantage over the conventional use of convolutional neural network, which is used in radiology primarily. When you are looking at a time series data like a ECG or an EEG data, which is kind of dynamically changing, or like you said, from a loop recorder of the Holter, you will probably want to use in the earlier days recurrent neural network, but now I think even a part of generative AI can be utilized in looking at.
There is a set of models. I read a paper recently where there are specific models for time series data in medicine. So I think there are some specific models. I'll have to
we generally use LSTM model.
LSTM, yes.
Yeah.
Right.
LSTM is a highly recommended model, but again, you may have to consider other model also, but LSTM always gives a better result.
For now, that's good enough. Thank you very much.
Thank you, sir. Thank you.
Okay, let's see some more questions. Dr. Shripal wants to know, before that, Dr. Nitin wants to know, can I use data from my existing EHR to use some AI application? Dr. Nitin, you want to really tell us exactly what you want to do in terms of using your EHR? You can come, just unmute and ask the question. That will make the question more relevant, actually. Dr. Nitin? Okay, so I will Okay, so I will just kind of give you an overview. See, the first thing is when we are using data from the yeah, I can see Dr. Nitin on the screen. So you want to ask the question again and clarify exactly what kind of data you are looking at. Are you able to unmute? I think you have access to the microphone. No? Okay. So one important point, when we are trying to use the whatever data we are looking at in